Hello everyone from UHD Math and Stats Center. Today we're going to talk about what a derivative is. First of all, a derivative is a function that gives the slope of a tangent line to the curve at a given point x. So let's take a look at this graph here. Here's my f of x, this curve, and here's the point x, and here's the tangent line to the graph at the point x. So what a derivative does, it gives you the slope of this line at this point x, but at this point we don't know how to find the slope of a line using a single point. But what we're going to do is we're going to use what we know about finding a slope of a line using 2 points. So the formula for finding the slope of a line using 2 points is m equals y2 minus y1 over x2 minus x1, which is the same thing as delta y over delta x, also rise over run. So let's look at the second graph I've drawn. Here's my point x. Let's put another point on the graph. Okay, and so this distance right here will be delta x, change in x. And this point becomes x plus this change, x plus delta x. And the y value that corresponds to this point is f of x, and the y value that corresponds to this point is f of x plus delta x. So using this line here, the slope of this secant line right here would be m equals f of x plus delta x minus f of x over x plus delta x minus x. So we can see that at the bottom, positive x and minus x cancel out. We get f of x plus delta x minus f of x over delta x. So this is the slope of the secant line going through these 2 points. This is also called the difference quotient. Difference quotient. Okay. So this slope right here is the slope of the secant line going through these 2 points, which is an approximate to the slope of this tangent line at the point x. So what we need to do, if we make this delta smaller and smaller as it gets closer to the point x, we're going to get closer to the exact value of the slope of the tangent line at this point. So what we need to do, take the limit of this difference quotient. The limit of delta x goes to 0. We're basically saying that delta x is getting smaller and smaller, so this point x plus delta x is getting closer to point x of the difference quotient x plus delta x minus f of x over delta x. And once we compute this limit, we're going to get the exact derivative to the curve at point x. And this is known as finding the derivative using the definition. We are going to get the exact instant slope at the given point x.